All right, so quiz 1. The N is just how many, tell me that's not going to cooperate. Okay, N is just how many data points are there. Most of you did really well on that. It's just 20. The mean, now you did this, sorry, I just noticed it says you may add symbols to any unlabeled angles if you wish. That's what happened when you reuse quizzes. Just edit them. I never noticed that before. Okay, the mean, you add them all up and divide it by how many you have. So the mean is 76.45. The median is 78. The mode is 84 because 84 actually shows up 3 times. A couple people put 86 and 77, but they're only there twice. And the range is the highest minus the lowest, which is 34. Okay.
65 is also 3 times.
65? No. 66 and 65 and 65.
All right. Sorry. Yeah.
Okay. All right. I mean, I like you pointing that out because I certainly do make mistakes, but not this time. Okay, N is 12. Hopefully you didn't actually have to count that because it's 1 for each month. The mean is 20.25, or sorry, 0.025. And we should put degrees Celsius. The median, 4.25. To do the median, you have to redo them in order. You can't just, because they're not sorted in this order. They're by month, so you need to write them in order to find the median. That was the mistake that most people made. And then because there are 12 of them, you have to take the 2 middle numbers and take the average of them. Okay. There is no mode because there's no number that shows up more than once. And the range is, again, the highest minus the lowest, which is 37.6. No, it is, I don't know what the numbers are, but that's the answer, 37.6 degrees. Okay. No questions so far, so we'll go on. The mean height of the 6 children in a family is 127 centimeters. It gives us 5 of the heights and asks how tall is the remaining child. So I gave you a little formula that says the sum of n data points is the mean times the number of data points. So our sum is going to be the mean, which is 127, times 6, which equals 762. And if I add up all of the other numbers, if I add up the 99 plus 110 plus 118 plus 145 plus 167, that equals 639. So then we have to do 762 minus 639 equals 123. So that's our last child is 123 centimeters. Okay. Any questions on that? Okay, quiz 2. Okay. For question 1, the answer is that why are frequency polygons better for comparing multiple data sets than histograms? You can put multiple, oops, trying to spell, multiple data sets on one graph. Okay. 4 groups of students recorded their pulse rates after a 2-kilometer run. Determine the standard deviation of group 1. So for this, you just are going to do it on your calculator, okay? And you're going to get that the standard deviation equals 23.4. Now, a lot of people got 24.3, which is the S value. So that's actually wrong. You need to make sure that you're getting the sigma off of your calculator. Okay? Is there anybody who still needs help figuring out how to use their calculator to do this? Oh, I'm going to clear your answers. Okay? So, can anybody need help with this still? Dom? Okay. Okay, Dom, why don't we stick around after I go over the quizzes, and I'll make sure that you can do that, okay? Because they're all different. Every calculator is different, and I need to look up your calculator. Okay, cool. All right. Question 3. The question is asking which company's packages have a more consistent mass? Well, that's exactly what standard deviation measures. So the one with the more consistent mass is the one with the smaller standard deviation. So it's company B. So your answer is B, smaller standard deviation. And for question 4, it's the same. It's just one more baby step because you have to calculate the standard deviation for each. So for Shaden, the standard deviation, and we're always going to use sigma in this course, is 7.925. And for Melina, it's 5.878. And again, some people used S, and that's not what we're using. S is for a sample population, and this is all of the data that we have. This is all that they did for that day or whatever. And so who's more consistent, and how do you know? It's Melina. And again, the reason is that she has a smaller standard deviation. I'm just going to pop over to Classroom and see if anybody's there having trouble getting in or anything. Nope, no messages. Okay. All right, any questions on quiz 2? Okay, let's go to quiz 3. A set of data is normally distributed. What % of the data is within one standard deviation of the mean? So if you remember, our normal distribution curve looks like this. Hi, Lily. Hi. Yep. Here, no, come lie down on my box. Here. Good girl. Girl. Okay. Oh, she wrote on the screen. No, Lily, you gotta go away. Oh yeah, sure, start purring, and I can't resist you. Okay, I'm sorry. If this is our mean, here's the mean, and this is one standard deviation. There's 34% in here and 34% in here, and then I'm just going to do the whole thing. Somebody can remind me what these numbers are. I think this is 13.5. Is that right? No, you can't lie on my computer, honey. No. You can, here, come sit there. You can lie down there, okay? You can lie down right there. Okay, and I don't have my formula sheet handy. Is it 2.5 in this last one? Actually, we don't do this line. It's not the line I wanted to erase. 2.5 and 2.5, right? We don't do that line. Does that look right? Nobody gonna answer me? Let me grab my notes. To grab the right one. Oh, it's 2.35. Okay. 2.35. Sorry about this, not so professional, but this is what happens when you don't have a room you can lock yourself in. Okay. All right. So what percent of the data is within one standard deviation of the mean? That's this yellow zone here. So the answer is 68%. C. And what percent is within two standard deviations of the mean? Is this whole range here? And that's about 95%, which is D. And a set of data is normally distributed. What percent is greater than the mean? That is going to be 50%. It's how much is more than here. So it's all of this stuff. Okay, so that's going to be 50%, which is again D. Whoops. And which description does not describe the normal curve? So it is shaped like a bell. It does start off increasing. It is symmetrical, but it is not always increasing. That one's wrong. It starts increasing and then it decreases once you get to the mean. Hi, kitty. Hi. Yes, I love you too, but you're in the way. Okay. Is that okay? Any questions on that? Question 5. The age of participants in a bond spiel are normally distributed with a mean of 40 and a standard deviation of 10. So for this, you want to do a quick sketch. That was weird. Okay, we've got a mean of 40 and a standard deviation of 10. So if we go up one standard deviation, we've got 50. If we go down one, we're at 30. And if we go down another one, we're at 20. So if I remember my numbers from above, this is 34% in here, and this is 13.5% in this area. Sorry. So the answer is 13.5%. Okay, you could do it with z-scores and you would get something very close to that, but you don't, when we did the lesson on this, you didn't know how to do z-scores, so you don't need to. This is all you need to do, okay? Question 6, oh, same thing. I'll use the same thing, same drawing. So the ages are normal mean of 40, standard deviation of 10. How many are older? What percent are older than 60? So this is going to be 34. If we go to 60, it's going to be 13.5. And we don't. This is not 2.35. Or is it? Yeah. This whole section is not 2.35. The 2.35 is actually just to the next standard deviation. So what we have to do is take the 50, that 50% that's less than 40 years old. Sorry. How am I going to fix this? Okay, so you need the 50% that's less than 40, and then you're going to add the 34% that's 40 to 50. Go away. Oh, sorry, that's not what I meant to hit. Ah! Sorry, where did that thing go? Share screen again. I'm going to move this back up to the top of the thing. Okay, so try this again. So the 50% is less than 40. This is the 40 to 50 years old. And we're going to add the 13.5%, which is 50 to 60 years old. And that's going to get us a total of something. My cat is lying on these. Sorry, honey. You guys all have cats, right? You know what they're like. And the answer, and that's actually what's less than, that's going to get me 97.5. So that is less than 60. So 100 minus 97.5 is 2.5%. And that's my answer. 2.5% are greater than 60. Okay, any questions on that? A teacher is, oh, I don't see any questions, so no questions so far. A teacher is analyzing the class results for physics tests. The marks are normally distributed with a mean of 76 and a standard deviation of 4. This is just counting on almost, this is 76 minus 4 equals 72. B is going to be 76 minus 2.5 times mu, or times 4, which gets me 66. Okay, those ones are probably the easiest questions on here. One of these sets is normally distributed. Which one? If we look at these, A is the answer, so I'm going to start with B. So B starts off big and continuously gets smaller, so that doesn't look like a normal distribution curve. C kind of jumps up and down all over the, oh, it actually starts high and goes down. If you were to graph it, it's like a canyon instead of a mountain. That's not right. And D, if you were to graph it, would look sort of like this, where it's not centered, so it's not D. So the answer is A, and the reason that you could give is it appears symmetrical. That's probably not enough to say that it's normally distributed, but given that you know that one of them is normally distributed, that's the only one that can be, so that's going to be your answer. All right. And then for question 10, the answer is, I'm going to type it up because there's my writing is just atrocious today. So the answer is bell-shaped curve, symmetrical, and mean, median, and mode are all close to equal. Okay. There are more characteristics that, the 68% of the data is within 1 standard deviation and whatever percent is within 2 standard deviations. But these are the 3 important ones that I'm looking for. Okay.